So in the security industry, the big topic, one of the big topics today is gun and gunshot detection. And we have our hearing protection here. We've been doing some testing today, and you guys were a part of that. I appreciate you being here. Talk to me about what Bosch is doing as far as gunshot detection, audio detection. Where does that sensor reside, and how does that work?
So the original technology of the gunshot detection came from the SoundC. The original audio AI came from that technology, but then we have heavily engineered it and also tested a lot. If you think of this technology, there are three main portions. One is the MEM sensor, the signal processing, which is in software and hardware, and then we have the audio AI, the machine learning aspect of it.
All in the camera?
Yes, all is on the edge, and that's the advantage, that you don't have to send anything to the cloud. Everything is done on the processor itself.
So everything's living in this housing. Everything you say is living on the edge, and there's a lot of different benefits for that when it comes to like video surveillance, as far as how much data is going across your network, those sorts of things. What else is an advantage of being placed on the edge?
The speed from an event occurring to when you're getting an alarm is much faster. Like Ajit said, the audio is being sampled 4 times every second. So from using today, gunshot, from the time a gunshot occurs to the time the camera detects the gunshot and starts sending out alerts to your VMS, between 250 to 500 milliseconds. Whereas if you're using a computer up in the cloud running some big AI model,
or in your server rack,
you're at the mercy of the latency of your network to get your detection, and then from there even more latency to get it out to whoever needs to see this detection.
Yeah.
Whereas we cut out one of those steps.
Right. Plus the processor, which is a high-end processor, right, on this camera, allows you to run those AI models at very high speeds. They are tens of milliseconds, as opposed to if you are sending data to a cloud. So
I guess just like anything, the less friction you have in between, the better, right?
That's correct.
And so if everything's in the camera, I mean, today we're all calling them sensors now. So it sounds like that housing has a video component and an audio component for surveillance and things like that, but also this detector technology, which is audio based as well, for gunshot. What does that look like in the camera, right? Like, is it listening? How do you measure when to create an alert that there's a gunshot versus suppress that if a car door slams or somebody drops something in the hallway?
It starts with the MEM sensor in the housing, which is then connected to an audio codec, which converts the analog signal into the digital component for the system. The system then is taking in that digital signal. From there, it's being converted into what's called a spectrogram. It's a picture of sound for all intents and purposes. That picture of sound is then given to the AI model. The AI model then predicts whether this is a gunshot or not. That AI model has been trained with at least 10,000 gunshots of 20 plus different firearms, multiple different distances, along with at least 200,000 examples of false positive information. So
that sounds like a bigger problem, is the false positive, right? Like, getting the gunshot is one thing. Suppression of a lot of environmental factors is a much bigger deal.
Right. And that's just one of the keys to our system. If you take the spectrogram of each gun and you observe it, you will see that they are different. And then you also see the spectrograms of other audio events. Say, for example, if you're playing sound through a gun, or you shoot a gun and then you play a sound of a gunshot through a speaker.
A recording of it.
Right. Yeah. And like a high fidelity speaker, for example, and you compare the spectrograms, it would be completely different.
We originally started with this, because it's difficult to test with a gun, right? So we started with a speaker.
Don't worry, that's one of the questions I'm going to get to as we go. So go ahead.
So we were just playing audio recordings of a gunshot through a speaker, and that was fine in the very beginning stages. But eventually, the AI got so good that it just wasn't working.
How long ago was that you started this?
This was almost 2 years ago.
2 years ago.
So where Jacob and I, basically, we were testing at different distances. We bought a very high fidelity speaker from Bosch, and we would we would clear the sound of that gunshot onto our system, and that's what our target was, detect that sound. As we started actually then, actually going to the ranges and testing with different types of guns, and as we started incorporating that data into our system, you could already see that the speaker-based gunshot doesn't work anymore, which is what we desire. Right? So
the speaker can't produce the sharp impulse sound that a gunshot can, or a car backfiring even. It can't produce such a dense signal of all the frequencies. Right. It because of how the speaker moves, it oscillates. When you look at the spectrogram, there's, I'm going to call them gaps in the sound almost.
Right. And I think we have broached the topic of data also, that now that you have gunshot sounds, we know that customer environments are going to be different. You're going to have retail, you're going to have traffic, you're going to have, theaters, things like that. Outdoor right. is another thing, which is a configurability in our system. But what we have done is taking all those thousands of gunshots and we augment that data on top of environmental sounds. So we have hours and hours of recording of traffic, right? We have hours of recording of fireworks on July 4th. And that's been, so data is one of the strengths of our system. That's why we also feel confident of that.
Speaking of confidence, when folks listen to a sales presentation or a demonstration, there's a certain level of understanding and it's a very broad discussion. We would like this technology. A salesperson or whoever says, we have that, let's talk about a design. But where the rubber really hits the road is once that device is in the installer's hand and they're going to mount it to a wall, a ceiling, on a parapet mount, whatever they're going to mount it to. What is the complexity and how confident can they be in the installation being done properly? Like the examples I used throughout today as we were doing our testing were if I put up a visual camera, I test it by looking at the screen, right? I can see. If I put up a fence sensor on a motion detection system on a fence or fence cutting, I shake the fence and I see the alarm. Gunshot is a whole different story, right? Most folks aren't going to be too excited to be shooting guns around their property. So the installer arrives, goes to put these up, talk through, the complexity that they may or may not encounter, and how does somebody test this thing?
Right. So it is 100% true that it is very difficult to test a gunshot system, right? And you cannot be certain 100% unless you shoot a gun and see the system react. What we had done is a couple of things. One is we want to make sure that the default experience that person gets without much intervention is the best setting, which is where we have selected the thresholds, the gain levels that we have in our cameras that are best suited for what we have tested with, right? What we have tested with outdoor, we have tested indoor models, and we have tested, against all false positives, and we have selected a threshold that is recommended. However, if you are an advanced customer, you know your environment, you have those knobs, you can change them.
Okay.
Right? That's one thing. But then second is, if you just want to test our system that, okay, I have installed this, does this even work? Do I even get alarms? So you have the fire alarm testing in it. You can do a carbon monoxide or fire alarm test and see the entire system running.
All right, let's hold up there for a second. That sounds very simple. I'm going to do a fire alarm test. What is that? So the camera, the sensor is now listening for the specific range of a fire alarm and kind of like what does that mean?
Right. So it's the fire alarm is T3.
T3 and T4 alarms, right? They're the standardized sound for a smoke alarm and a carbon monoxide alarm, respectively, right? I can tell you how we test it, and this is a good test to determine, one, if your device is sending alerts to your VMS correctly, and also to verify that the microphones aren't gunked up with something, right? If they're gunked up, you can't hear anything.
Well, let's assume that when they get installed, they're not gunked up.
Right.
But perhaps every year I want to do testing on this, right?
Correct.
Yeah.
What we did is we just bought fire alarms and smoke alarm or carbon monoxide detectors, and we push the test button, makes it sound, make sure the camera can hear it and detects it properly.
So that way you're at least testing one aspect of the system. Second aspect is the demo mode. What we have done is we have uploaded clips of maybe 15 different types of guns into the camera itself. And when you play those sounds, you're actually running the same AI model that you would run as if you were doing a gunshot testing, right? So even though it's very difficult to do a live gunfire inside a retail store to test, you can at least use these methods to build your confidence that that system is actually doing what it's supposed to do.
Okay, so those are good for some basic testing. I think I heard you guys say earlier today that firing blanks would be an option.
Right, so we have incorporated blanks because this has been one request that, hey, we'd like to test it so that, you know, if instead of live, it's blank. So this hundreds of blanks fires shots have been captured, trained, the AI is trained to it, but that's not our main focus. The main focus has been the actual gunshot sounds.
Okay, so the fact remains, if I really want to truly test this, I need to make some arrangements and have some sort of live fire exercise to
I think so.
do that.
Yeah.
Because any other way you test it that isn't a live gunshot, in a way that's a false positive detection.
Right.
The system's meant to detect gunshots, and that's ideally the only thing it detects.
Right. But they can, on the other hand, you can do other kind of testing, which is false positive testing. You can do balloon popping, you can do car misfire, you can do all other kinds of audio events which you think like a firecracker or something like that, where you want to see if your system would actually create a false positive alarm.
That
right?
seems a little less stressful to everyone involved to do false positive testing, right? So we've talked about the sensor inside of this thing. In the security industry, because we're talking about a housing that has multiple technologies in it, in the security side, video surveillance, the idea of recording audio comes up a lot, right? Perhaps if you're doing a police investigation and you have a person who you're asking questions, you want to record that kind of audio. But for the most part, most security folks steer clear of audio. So now I go to get this device and I'm going to use it for dual purpose. You know, can I turn the audio off and let it still detect gunshots? How is audio privacy handled?
Let's start with the scenario where you want to turn audio off on your system and you want the gunshot detection to be running as well. The audio used by the system that you're turning off is completely separate from the audio that the gunshot detection system is running on. One, because of this privacy concern, and two, let's be honest, telephonics communication audio quality is not good enough to detect a gunshot reliably, right? So it's a dedicated audio stream just for this detection, and that stream in and of itself is never even accessible from outside the camera, even if you have audio enabled.
Right. So those are, as Jacob said, those are independent aspects. The MEMS sensors that are used are basically selected where their acoustic overload points, their frequency spectrums match what we want to do, and we know that they won't saturate, and we can do, you know, smaller or larger gunfire systems detection. But they are just going one step further. We sample every second the audio that's coming in. We process it, as Jacob mentioned. We do the signal processing. We have the spectrogram. We have our AI running. But after that, that clip is thrown away. So there is no recording. That's not going into any storage of the device.
So the only way somebody would hear a gunshot later is if they were recording the surveillance audio.
Right.
Correct.
Okay. Is there any connectivity outside of my network? Meaning, does this have to be connected to a cloud service? You know, what is the architecture of this system? If I have a closed environment like many people do, whereas a lot of people don't. They don't mind sending a lot of data to the cloud. So
So one of the strengths of this system is on the edge, which meaning that there is a high-end processor running in it capable of running AI and machine learning. So the system does not require any data coming from the cloud, right? It's your choice if you have a VMS or if you have a system that you want to communicate to your camera, whether you're sending video or any other data, that's your choice. But in terms of audio AI, it can be completely independent, give you systems. It could be a closed network, and you'll be self-sufficient.
So no GDPR issues, no US-based issues with privacy.
No, not for audio AI. We don't have any of those issues. There's no recording done on the camera.
Okay. We are out here, we have been out here today shooting a lot of different weapons. Our guys don't mind in any way helping you do your testing. And on these tripods that are back here are not only what's available today, which is the FlexiDome 5100i panoramic. There's a couple other cameras that you guys were working with today. Can you just briefly tell us what's in the future for the gunshot detection system?
Right, so right now it's on the 5100 and the pano cameras. It's being worked on the other cameras as well. So we are currently testing those. So the goal is to extend the same technology on other cameras as well. As far as other use cases, there is anomaly detection is a big topic nowadays, where if you know your environment and you know your acoustic signature of your environment, then if you want to detect something abnormal, right?
Screeching tires
or accident or
screaming
sound. As long as the camera has enough signal to noise ratio for those sounds, we can detect it, because the AI
can, or that's what's coming.
That's what's being worked on, and we're working on it.
As much as I would like to say, I hope you're done with testing and evaluating and it's just 100% good to go. We know that's not always the case. People like you guys are continually working to make these things better, more reliable, react to new threats and things that our security partners and safety partners are worried about. So thank you for being so diligent and sticking with it. We look forward to bringing the equipment out to help you out with that in the future. So thank you very much.
Thank you very much.
Thank you for your support as well.